detailed diagrams of it. It's just বুঝানোর জন্য tube ওই নোট থেকে নিয়ে আসি। Right, so this is the apparatus. আমরা CRO use করবো না এখানে। CRO use করতে চাইলে করতে পারো, অসুবিধা নাই। But the idea of this is the setup, the experimental process, and একটু গুছাই দিই তোমাকে। And this is like the reasoning. Right, so there you go. This is basically the same diagram. আজকে যেটা বুঝালাম ওটাই, so for reference রেখে দিলাম এখানে। Yeah, so that's what happens here. I'll just read whatever is written here. It says we take sound source connected to a frequency generator and vary the frequency until stationary waves are formed. This can be confirmed using fine sand that creates a pattern representing a stationary wave pattern. The places where the antinodes are generated leads to the formation of large gaps in the sand. When antinodonic vibration হয় সবকিছু সরায় ফেলে এখান থেকে। This is because antinodes are points of high amplitude. The sand gets displaced and gathers in place of no vibration, known as nodes. We can measure the distance between nodes and antinodes to determine the wavelength. Node to node represents lambda by 2. So yeah, that is what this is. Right, so that is the experiment that you have. Now there's another version of this. এটা তো হচ্ছে air column নিয়ে করলাম আমরা. There's the one with microwaves. Microwaves is exactly the same thing. আমি তোমাদের diagramটা দেখাই, but there's one extra part to it. So এই part থেকে একটু বুঝাই নিতে অনেকে। So microwaves এটা হচ্ছে this. Okay, so there's this one extra question we need to answer. Microwaves. I'm basically trying to wrap up station waves today. So এখানে just এইটাই বাকি, তো এটা করে নিই আমরা। So let me explain what the microwaves deal is. Right, so what happens with microwaves? Same thing. You want to find the wavelength of a microwave, right? So microwave কি করবা? You'll take a microwave generator. You'll produce your microwaves. Microwaves যাবে দিকে reflect করে back করবে. Stationary waveform হইতে পারে, না হইতে পারে। তোমাকে frequency generatorটা এটা করে নিতে হবে, tweak করতে হবে until it forms. Unfortunately, microwaves are not a mechanical wave, so they can't really displace anything. Because they can't displace anything, what happens is that you need to do the trial and error process. Okay, so you do your trial and error process and find out where your microwaves produce stationary waves. How you know that they produce stationary waves? You find, like, region of high and low amplitude, right? Now the thing is, আমাদের সিলেবাসের রিকোয়ারমেন্টে that this graph shows up. So if you take a CRO and you move your microwave from left to right, you'll find that the structure is a little odd. It was supposed to be this high and low, high and low. At the places of node, you're supposed to have 0. The places of antinode, you're supposed to have maximum. So it's supposed to be like that, right? But rather, we find that it forms something like this. That it forms your maximus and minimus. Maximum uniform object. But it's a decreasing maximum minimus. Does anyone have any suggestion as to why this happens? Why is the amplitude decreasing as it goes up and down like that? Like why isn't it a consistent up and down? Right? Why is it a decreasing up and down? Yes, very good. Sandite. But you're right. Standard reason the energy loss. So do you know what's happening here? As the waves are generated here, right? Waves will generate they travel. What do they lose as they travel? They lose energy, right? So as they travel like this, they reflect and come back. ওরা perfect constructive and destructive interference করতে পারে না। So what they do is they create like a maxima that's based on two ways that look like this, which means maxima হবে না, and they create a minima that's based on two ways that look like that, which means minima হবে না. So what the problem is going to explain করি is that when the waves are interfering with each other, আমরা সবসময় assume করি একটা জিনিস that যেটা এরকম ওইটা এটার সাথে ইন্টারফেয়ার করবে so ডাবল হবে, আর যেটা এরকম ওইটা এটার সাথে ইন্টারফেয়ার করবে তো যেন ফ্ল্যাট হবে। But unfortunately ওয়েভটা শুরু হয় এরকম করে, but as it travels further and further ওয়েভটা কিন্তু এনার্জি লুজ করতে থাকে, and it loses energy and loses energy, and by the time it reaches here it has lost a lot of energy, and then it reflects again, so it loses even more energy. So by the time it reaches here এটা এরকম দেখতে হবে যেটা এটার সাথে ইন্টারফেয়ার করবে, and as a result তুমি পারফেক্ট ডাবল অ্যামপ্লিটিউড পাবা না। অলসো ডিস্ট্রাকটিভের জন্য তো আরো বাজে অবস্থা, এটা এরকম দেখতে and it interferes with একটা যেটা এরকম দেখতে। So will you have a destructive interference? Yes. But will you have an actual destructive interference where the amplitude is 0? No. তার জন্য তুমি একটা মিনিমা পাবা। Yes, it is true যে যেসব জায়গাগুলো হয় you get a minima, but not the least minimum possible. মানে what I try to mean is that it's not going to be a 0. And that's the reason why as you keep going further away from the screen, you'll notice the এরকম একটা pattern follow করে। The pattern of your intensity change over distance. So ওইটার সাথে মিলেই ইন্টেন্সিটিটা ভ্যারি হচ্ছে, and that's how your nodes and antinodes are also being set up. So as you start to move away, what happens is your nodes and antinodes are still forming, but they're not perfect. So as a result, you don't have the perfect anticipated shape that looks like this. So yeah, that is the reason why. I mean, like this, as we move the detector, we can notice that the overall intensity is decreasing exponentially. This is due to inverse square law relationship between distance and intensity. However, we notice maximas and minimas along this graph. These are nodes and antinodes. So you can still find your lambda by 2 into, because lambda by 2 is going to be the distance between any two minima. So you do have your minimas here. You just find the distance between these two, and you have your distance provided. So yeah, that's the microwave version of your stationary waves. Right, so there you go. There's this one small topic left from stationary waves, which আমরা next class করব, and I'll be starting the last part. Diffraction একটা অনেক ছোট, it takes like one class to wrap up. So our aim হচ্ছে when we resume our classes ওই break এর পরে I want to start with electricity. Maybe I'll take a couple of classes. Electricity auto important in the overall context. The wave is more important, wave chapter. So I'll probably take like a couple of classes to do some MCQs here, so that you can try it on your own as well. AMCQ gulo, you can't skip a single one of them. Okay, I know there are like 100 of them here, but you need to do 400 of them. মানে waves থেকে, and the recent papers গুলোর সবগুলো মিলে 400ই হয়. So it's extremely important that you focus on this. And waves বুঝার best way হচ্ছে MCQ use করে, because it's all concept. So once you understand your MCQ, you'll find your structured paper questions are much easier to solve. So MCQ গুলো খুবই important, okay? So I'll not rush into electricity just for the sake of finishing the syllabus. I want to make sure that waves টা বুঝে আগে, so that when I'm doing electricity, you can do waves for practice by yourself at home. Okay, so yeah, maybe second week of January I'll start electricity. Electricity syllabus change, because the last chapter is not even a chapter, it's a topic, particle physics. Okay, so yeah, that's the aim. I wanted to keep this wrapped up a stationary wave part though, because that's important. Airport on the diffraction does, but diffraction 1.5 to get 2 classes lage, but yeah, again, I don't want to rush these. They're very important conceptual topics. Okay, so I will try to take another class এরকম a week মধ্যে. I'll let you know. Google Classroom to check for the timings. Okay, this regular timing না নিয়ে অন্য timing গুলোতে নিব, so just keep an eye out for it. Okay, so yeah, I will let you know when your next class is going to be. And those who didn't give the mock, you still have tomorrow to make it up. Tomorrow পরে আর mock দেওয়ার possibility থাকবে না. Okay, tomorrow is the last day. So if you have missed it, you have to wrap it up by tomorrow.